Wade.
Hey, Carly.
So today we're going to talk about sample space.
Awesome.
And the sample space is just the set of all possible outcomes of an event.
Do you have an example?
Yeah, so let's go ahead and look at this die. The sample space of rolling a die once would just be any of these numbers. So that would just be 1 through 6. And a lot of times you'll see the sample space actually written in curly brackets and then all the possible outcomes. So this is a super simple example with rolling one die. We can get any of these, and all of these outcomes have a probability associated with it. So probability is one scenario where the sample space can really help us because we can think about all the possible outcomes of an event and then think about, okay, what are our desired outcomes and calculate that probability.
So if we build a simulation, we really have to think about this sample space to really think about all the variables that take place into actually making a simulation.
Exactly. And we've talked a lot about simulations, and that's another scenario where the sample space can come into play, especially if you're doing this 1,000 or 10,000 times. So Wade, let's do another quick example. Have you ever played tic-tac-toe?
I love tic-tac-toe.
Okay, amazing. So we can think about the sample space of all possible games of tic-tac-toe. And Wade and I could sit here and play, I guess, however many games we would need to get all the possible outcomes, but that would take forever. So instead, we can use Python to create a simulation of this.
Yeah, so if we want to think about the sample space, I think one of the best ways is just like think about a game. So what does the board look like in tic-tac-toe?
So in tic-tac-toe, if you're not familiar with it, we have a board, I think, that looks like this.
Looks great.
3x3 board. And basically, you want to get 3, so one player is the X's and one player is the O's, and you want to get 3 in a row.
So the sample space is going to be every single possible combination of X's, O's, and blank spaces in this entire board. So that means that there's a whole lot of different possibilities because there's 3 different possibilities for just this square, 3 different possibilities for this square, 3 different possibilities for this square, and a huge number of possible combinations.
And then we need all those combinations. So Wade, do you want to play really quick?
Let's play.
Just to see. I haven't played tic-tac-toe in years. I'll be X's.
Okay. Oh, you went for the side, not the center. I'm always a fan of the center.
Ooh, so, okay.
Uh-oh, yikes, you're about to win. I think I can win.
Oh, delete that part. Anyway, so one thing about this game of tic-tac-toe is that Wade and I are strategically, well, I wasn't being very strategic, but Wade and I are strategically trying to place our X's or O's so that we can win. So if we simulated this with a computer, we would have to, it would be very complicated to do it with the computer kind of thinking about that idea of winning, but it would be a lot easier to do it if we just simulated it randomly happening, where the computer would randomly put an X or an O in whatever spot.
Yeah, I should have been a dumb computer. I was trying to be too smart here.
I was the dumb computer. And that's sample space.